Okay, so something else to have handy in your back pocket is just knowing, particularly sine and cosine, of our quadrantal angles. And so what a quadrantal angle is, it's just an angle on the x-axis or the y-axis. And I'll show you what I mean. So if we take our circle, so an angle on the x-axis, like 0 or pi, or the y-axis, like 2 pi over 2 and 3 pi over 2. If we know sine and cosine of those right easily, that will help us out so much. And notice these are just regular points, right? 0, 1, 0, negative 1, and so on. All right, so sine of 0, we know is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. Kind of has a pattern here, 0, 1, 0, negative 1. For cosine, it's just shifted, 1, 0, negative 1, 0. And then you can just divide the two to get tangent. Sine over cosine, 0 over 1 is 0, 1 over 0 is undefined, 0 over negative 1 is 0, negative 1 over 0 is undefined. So these are good to know, to just remember the pattern, 0, 1, 0, negative 1, and that will help you a lot. Another important thing to know is the sign of our trig functions. So our trig functions could be positive or negative. Just like we see here, we get positive values in the first quadrant. We get some negative, some positive, both negative, some positive, some negative over here. All right, and so there's actually a mnemonic to help us figure this out. And it's called, which is not necessarily a true statement, but it's called all students take calculus. And I know not everyone needs to take calculus. All right, so A is for all. So that tells us in the first quadrant, all trig functions are positive. Right? So in our first quadrant, all of our answers here are positive. All right, next is S. So in the second quadrant, sine and its reciprocal cosecant are positive. So only sine and cosecant are positive in the second quadrant. Third quadrant is T for tangent. Tangent is positive in the third quadrant, so tangent and cotangent. And then finally, C is for calculus. Cosine and its reciprocal cosecant are positive in the fourth quadrant. Okay, so this can help us later in life, but let's talk about how to use it now. All right, so number 2 says, let theta be an angle in standard position. Name the quadrant in which theta lies. All right, so here it says, sine of theta is negative. Can you tell me what quadrants sine is negative in? So let's see. In quadrant 1, all are positive. So sine is not negative there. In quadrant 2, sine is positive. So it's not negative there. Sine is only negative in quadrants 3 and 4. Okay, so we've narrowed it down to quadrant 3 and quadrant 4 is where our angle will lie. Next, we know that tangent of theta is negative. So, in what quadrants is tangent negative? Well, only sine and cosecant are positive here. So tangent is negative in Q2, tangent is positive in Q3, and tangent is negative in Q4. All right, so which one is our angle going to be? Well, it's going to be the one where both of these have in common, Q4. So theta is in Q4. Okay. All right, so this can help us out if we don't want to deal with negatives right away. All right, so it says find the exact value of the remaining trig functions of theta in quadrant 2. Sorry, find the exact value of each remaining trig functions of theta where sine of theta is 4 over 5 and theta is in quadrant 2. All right, well, let's draw this out. Our angle is in quadrant 2, so that means it starts here, ends in quadrant 2. This is our angle. All right, we know all students take calculus, tells us which trig functions are going to be positive and negative. So we can think about this triangle right here, and you actually don't even have to think about it on the graph. You can just take the triangle out. All right, so sine is 4/5. That means opposite of our angle should be 4. The hypotenuse should be 5. All right, and then we can use the Pythagorean. This is a 3, 4, 5 triangle. Okay, and we can find all of our other trig functions just from this. We know cosecant theta is 5/4. We can find cosine theta, adjacent over hypotenuse. We can find secant theta, 5/3. We can find tangent theta, opposite over adjacent, 4/3. And we can find cotangent theta, 3/4. All right, so we know the trig function values. Now we just have to determine if they're positive or negative. So sine of theta equals 4/5 gives us all of this. The quadrant tells us if it's positive or negative. So we're in quadrant 2 here. What do we know about quadrant 2? Only sine and cosecant are positive. Everything else is negative. So sine is positive, cosecant is positive. Cosine should be negative, secant should be negative, tangents should be negative, and cotangent should be negative. All right. Okay, so let's talk about how we're doing this. So we're doing this using reference angles, and we're about to learn what reference angles are. So it's actually the special triangles we've talked about in the past, the 30, 60, 90, and the 40, 40, 45, 45, 90. So let's draw those. All right, so let's say this is 30 degrees, this is 60 degrees. All right, so tip, the smallest side goes with the smallest angle. So 30 degrees opposite that is 1. The largest side, which is 90 degrees, the largest angle goes with the largest side. So that biggest number is 2, and then √3. So this is our 30, 60, 90, and then we also have our 45, 45, 90. So these should be the same, 1, 1, √2. All right, so you do need to be comfortable with these two to be able to do this next section. All right, so I'll explain that now. Okay, so it says let theta be a non-quadrantal angle in standard position. The reference angle, we're going to call it theta r, is the acute angle that the terminal side of theta makes with the x-axis. All right, so it's these triangles that we've been drawing here. So when we open out, we can do this and make a reference triangle. We can do this and make a reference triangle. So notice that I'm always drawing the line to the x-axis. And I'll show you how to find those angles in the next video.